Hadoop and MAOut. So how Hadoop is just the integration of MAO and Hadoop, uh, having to take advantage of the Hadoop distributed file system and Hadoop ecosystem, let me say it that way, and using writing our programs on uh, and using the advantage of the Hadoop ecosystem. How it works in memory. So having to integrate Hadoop with how to be able to run very across files instead of in memory. And also we talk about outside by which is known for its machine learning libraries, which is uh, very useful to build machine learning models to run across data sets in the Hadoop ecosystem. So let's just see this objective. Here we're going to understand key requirements for data analysis on massive scale and also see how we can install and use RRD, perform text mining, and also understand MARS features. Even though, okay, let's just proceed. Now, the amount of data that is traditionally processed by typical statistical analytics tool and systems earlier used being in the range of 10 and hundreds of gigabytes. Definitely not in the terabyte and petabyte range, which is in the case of the big data. But traditional analysis require an expensive SMP machine with huge memory to hold data being analyzed because all the tools then were running in memory. So they run files equivalent to memory available on the machine. So if I have a memory on my machine is just let's say 100 gigabytes, I can't run on files that is bigger than that memory of my machine. So that's the limitation. So the reason behind this is that many analytical algorithms were quite compute intensive and were designed to run in memory as I've explained, as they require multiple and often frequent passes through the data. Now, they came about the sampling technique as a solution. So instead of me to run to run on the old data set, let's say the data set is like 1000 gigabytes. So maybe I have like 5 million rows, and the size of the data set is too much for me to be able to access it on my local machine and perform my analysis on it. Then we're going to just consider a sample. So out of that 5 million records, I might just take maybe 100,000 and use that sample to generalize for the whole sample, for the whole population. Okay, so since such hardware was not only expensive but also time consuming, analysts began working on only a sample of the data. So the idea was to use only a statistically significant sample of data. But obviously, finding a statistically significant sample can be challenging for sparse and skewed data sets, which are quite common. So to get a sample out of the population that can be a true representative of the population, it's very difficult to remember. So the scale of which analysis requires to be done is dependent on various factors and computation. Hello, I hope you can hear me.
I hear you.
Okay, so they rely on taking samples and try to generalize with the sample. So to make uh, to come to a decision with the sample. It's just like as we have the whole population of Nigeria, it's very difficult to find, let's say, the average salary of all employees in Nigeria. You have to start going in door to door and ask for information about, okay, so what's their salary, and you can't take everyone into consideration. You can't find everyone. It's very difficult to do so. So what we just need to do is to take at least a few, at least a significant number of people in Nigeria and try to compute their average salary. Then use that to generalize that okay, the average salary of people employed in Nigeria is among this one. So and that is also what we call the hypothesis testing of that. So some technical solution. So these factors and complications include following the volume of data on which analysis is done and the number of transformations required on data sets before applying statistical models because if you have a very large data set, you have to take some sample and perform some transformation so that that data will be fit for what you want to use it for. Then the number of pairs correlation needed to calculate the degree of complexity of the computations, and the number of statistical models to be applied on the data set. Also, now talking about Hadoop as a solution. So Hadoop provides a solution to the problem of performance analysis on massive data scale by providing a platform to perform massively parallel processing computations on data. So with Hadoop, you don't need to take sample, you can run your analysis on the whole population instead of taking samples. So why Mapping is a solution for parallel processing of good data sets on our data, converting statistical model to run in parallel using MapReduce is not easy. So because MapReduce is written in Java and not everybody is comfortable with writing Java programs to do like that. So not many analysts or statisticians will be able to handle MapReduce programming efficiently. So as a result, Hadoop developers keep working on solutions for implementing the algorithms required to perform statistical modeling analysis without overburdening the analyst with knowledge of parallel programming. And two such tools include integrating R with Hadoop, or what we call R Hadoop DAO, a project that was started by Revolution Analytics, and now they call them Revolution Analytics. And also talking about MARHouse, it's multiple statistical models and library functions. Okay, so let's uh, recap on Hadoop. So we talked about this in the first module. So Hadoop is an open source software application that provides a distributed storage, which is HDFS, and computation capabilities for processing large amounts of data, which is MapReduce. It is based on distributed file system and allows users to perform parallel execution of programs on a group of computers called Hadoop clusters. Something like this can come up in your examination exam. Parallel execution of programs on group of computers, known as what? You can say Hadoop cluster, MapReduce cluster. You can give you options like that. Let me. I think I have a question like that. Maybe stored on my PC. So I think I have. So the HDFS component contains the following two subcomponents: name node and data node. Hold on, give me a minute. Um, I think I have it here. I think I have this. I want to show you something here. Okay, so I want to take a look at one example like that here, one illustration. I don't know whether it's have it saved here. Here. Uh, um, is that it? No, it's this. Okay, okay. Maybe this information used to complete a large amount of data in a Hadoop cluster. Uh, not, I don't think this is the question I'm looking for. Okay, I think MapReduce is a framework used to compute a large amount of data in a Dash cluster, like given HDFS, Hadoop, Spark, Hive, HBase. So you can see how they coined the question. Can you see my screen? Okay. So Hadoop distributed file system is the storage component of the Hadoop platform. I talked about this. I said the HDFS component contains the name node and the data node. Now, the name node is the one that keeps the metadata. Metadata simply means data about data. And so you can keep some information like, okay, when was the file created, when was it edited, deleted, when was it updated, and stuff like that. So it keeps those information. And always the file location and all of that. So keep records of data nodes and file blocks to manage the data nodes. And we have the data node contains the blocks of files and communicates with other data nodes to manage file read and write operations. Data node also communicate with themselves. They contain blocks of file, usually 128 MB. Usually 128 MB. So you can be asked such questions in your examination. So let me give you an instance. So let me give you an instance of that kind of question. I should say, look at this question now. Which of the following is not the part of 4 V's? Now, in your material, you have 3 V's. You have 3 V's, but veracity too, it also can be included. Veracity. Then the one that is not inclusive is visualization. So
Sure.
that's not what I'm going to show you in this. So I want to show you something. I think I have like two of them. Not this. Not this. Not this. Um, I think I already passed it. What is? Okay, let me go back. I think I've already passed it. Or maybe I didn't even have it. Let me check. Okay, look at this. Look at this question. Can you see this question? It said,
Yes.
how many blocks with replication factor 3 would there be in 1 GB file with 128 MB blocks? So here I have in 1 GB block, I'm going to have, so in 1 GB file, how many blocks will I have in 1 GB file? I will have 1024 divided by 128. That's 8 blocks. So I'm going to have 8 blocks. And if I have 3 replication factor, it means I'm going to have 8 times 3 of them, which is 24 in total. So I have 24 blocks in total. I hope that is well understood.
Yes. Yes. Yes.
Okay. So moving forward. Moving forward, I think I've talked about this. Also, data node also provides heartbeat to the name node to show the availability of the data node. So if at any point in time, maybe it provides heartbeat to the name node every 2 seconds. So after 2 seconds, if a particular data node does not provide heartbeat to the name node, then the name node unmaps the data node and assumes that it's no longer available. Okay, so moving forward to the next slide. Recapping. Okay, still talking about recapping. Now we have MapReduce, which provides a batch-based distributed computing environment for the Hadoop platform. So what do we mean by that? So it means every MapReduce um, program is run as a MapReduce job. Like there's a job you have to do that. Then it has to be so after a job completes, that's when another job is being carried on. So everybody is on a queue. So it's batch by batch. So this component performs parallel processing on large amounts of raw data such as data from social media, relational data from database, and also data then generated from user interaction. So it works with structured, unstructured data. So the map of this model enhances parallel processing by abstracting the complexities of the distributed systems such as parallel computing, working with distributed data and software and hardware failures. You don't have to bother yourself about all of this. It does that in abstraction. So map possesses a job by dividing it into small parallel map functions and in this function. But the optional part of MapReduce is the reduce part. So what do I mean by that? If you want to run a MapReduce job, some jobs does not require a reducer does not require a reducer. So the mapping part is the one that is compulsory because you want to split so if I want to perform a task then on a particular file which is going to split it maybe split it into 1,000 different equal parts. Then each mapper is going to work on each splitted part. Then if that result needed to be aggregated, then the reducer is going to come on board. But it doesn't require aggregation of all of those outputs, then the reducer doesn't come into play. Then it's not necessary. So take note of that. That the reducer is the optional part of the MapReduce task. Okay. Now integrating R and Hadoop. So R Hadoop is an approach for integrating R and Hadoop. It's an open source project that allows programmers to define their own map and reduce functions and directly use the functionality of MapReduce in R code. So here you can now write, instead of writing Java programs in MapReduce, you can write your own map and reduce, which as a function in R, then run it on Hadoop. So R allows programmers to make use of full features of existing environment of R and leverage the Hadoop platform. So if you're very good in R, you just have to leverage on Hadoop too, so that you can use the Hadoop functionality to get that instead of having to write MapReduce programs in Java. So R Hadoop includes the following three packages: RHDFS, RHBase, and RMR2. So in your booklet, I would advise you to go over these packages. They describe functions that come with it that can use. So each of those functions, they give you hints. So like the RHDFS, it contains five manipulation functions like hdfs.move, hdfs.rename, hdfs.copy, and the likes. So these um, explanations are inside your material, so I would encourage you to go over your material. Okay, so to having to install RDB, you need to install some R packages, R Java, R CPP, R JSON, PTOX, and all of that. I think we have like 8 of them here. So these packages are required for you to first of all install before you can use the RDB. I think we have 9 of them here. Yeah, 9 of them. And okay, moving forward. So you are using RAD to process a large amount of data stored in tables. To manipulate this data, which of the following RAD packages will you use? Since you want to process tables, then you are going to use the RH-based package. Okay. Now, I said text mining for deriving useful information. So what is text mining? It's a set of techniques and methods used for automatically processing natural language text available in large quantities. Underline that word, available in large quantities. Also equivalent to saying data mining. So this text can be in form of computer file. The aim of text mining is to extract and structure the text for quick analysis and non-literary analysis in order to discover some hidden data for automatic decision making. So it's you can literally say text mining is lexicometry plus data mining, trying to study structure of text. Okay, this is the second slide. Let me see how many people do we see have it? Yeah. Okay. Now, text mining process follows this. Include the following steps: structuring input text, adding language rules, removing useless terms, some terms you not necessarily use, then inserting after removing those useless terms, then insert structured data into a database. And then after we've done that, you can now start analyzing, like identifying patterns in the stored data we have stored in the database, then analyze the patterns to generate useful information. Um, so implementing text mining in R, we're going to use the TM package in this regards to for text mining. So you can be asked this question in your certification exam. What's the package used for text mining? The TM package. I think you would have seen it in your what's it called? One of your I don't know. You haven't taken your test. You haven't taken your test. So here, talking about MAOut is an open source project from Apache offering Java libraries for distributed or otherwise scalable machine learning algorithms. Underline machine learning algorithms. Underline word. So these algorithms include key machine learning techniques such as classification, clustering, association rule analysis, and recommendations. So I can also ask you. So let me ask. Uh, Classification, is it supervised learning or unsupervised learning? Is it supervised or unsupervised? Hello, are you there?
Hello. Sorry,
Yeah.
what?
So I said classification, is it a supervised learning or unsupervised learning?
Supervised.
Supervised. Okay. I don't know whether you are right. Clustering, is it supervised or unsupervised?
Eh?
Is clustering supervised or unsupervised?
Not sure. Supervised.
Okay. What did you say?
I'm not sure.
Okay, you're not sure. Okay, let me go back to classification. So why did you say classification is a supervised learning? Hello, are you there?
I'm here.
Okay. So I'm asking you because you told me that it's a supervised learning. That's why I'm asking you why at least something like made you say that classification is supervised learning. So that's why I'm asking how why did you call it supervised learning?
Because for you to classify something, you must have observed that set you're classifying. So you need to supervise what you're doing. Like say classified learning, or how did you put it?
Okay, I think you don't really understand what we mean by is it something supervised or unsupervised. So I'll just leave that to when we get to that stage. So MAOut can run independently, but it also implements the MapReduce paradigm. So it works within Hadoop and can perform machine learning over large data sets on Hadoop cluster. So you can run machine learning programs, build machine learning model, or the old data sets and how they cluster. So although MAUs are designed to work within Apache Hadoop context, they are also compatible with any system supporting the map with this framework. So we have three main categories. We have this collaborative filtering, clustering, and classification. Let's see, discuss about these three algorithms in the next slide. So talking about, first of all, we we are looking at the framework of MAOut over the Hadoop framework. So here, these are the statistical algorithm we have collaborative between clustering and classification. MAOut, you can also create your user-defined algorithm, so you can create your own algorithm if you feel like the inbuilt algorithms with MAOut libraries it does not fit what you need to do. You can create your own your own algorithm. Then it uses the map previous framework and also for processing. And you can it also use the resource management available in Hadoop 2, which is the YAN, yet another resource negotiator. Then it um, uses the distributed file system of Hadoop, which is the HDFS. Okay. So moving forward, talking about the statistical algorithm, we have collaborative filtering, which was specifically designed to serve as a recommendation engine used for used as a collaborative filtering algorithm. So MAT combines multiple clustering and classification algorithms to create more accurate recommendation based on input data. So example of those kind of recommendation engines that what YouTube actually uses and even some retail stores. So they're like you go on YouTube and you watch some set of videos and you log off. By the time you come back the next time, you'll be surprised the kind of videos YouTube will be recommending for you. Like, wow, how did they know that I would love this kind of videos? Then before you know, you keep watching, you keep watching, you keep watching. Till you even exhaust the data. So this is the kind of recommendation engines behind all of those things. This is machine learning algorithms. So the recommendations can be applied against user preferences, taking into consideration the behavior of the user by comparing a user's previous selections. This they also use this in retail stores. Okay, if I select this product A and this product B, I think you like product C, stuff like that. So very, very interesting. These are machine learning algorithms. And also talking about clustering, which is a form of unsupervised learning where the labels for data points are unknown ahead of time. So you can see this and you can have a clear picture of why classification is supervised. You are right, classification is supervised learning. Classification is supervised learning. So here and must be concluded from the data without human input. So why classification is supervised is that, take for example, your which example should I use? Your RGS analysis. The labels has been already defined. Okay, if this person transacts between 0 and 7 days, put it as this bucket. It's you that defined it by yourself. It has been decided. So whenever you run that script against the particular data set, it already know where to go. So because it's already been labeled. But clustering, you just say, oh, this particular data, let me to just group them into 5 clusters. You don't know how the algorithm is going to go about it, but it just give you the 5 clusters. But classification, you only if you find some people in this set of categories, okay, label them as this. So the label is already known ahead of time. So I think that verifies your concerns as regards classification as a supervised learning. So is that understood? Hello, hello.
Sorry, I stepped out.
Did you get what I said?
I wasn't here. I went to check something.
Okay, let's just forget about it then. So objects within the same cluster should be similar. Objects from different cluster should be dissimilar. So that's clustering for you. So clustering is just, oh, I give you data sets. It's unsupervised. I give you data sets. Then okay, I want this data set to be grouped into 5 clusters. That's the supervised part. But clustering is this unsupervised learning. So where you supervise is for you to now tell that you want this specific number of clusters. So if I say I want 3 clusters, then it's just going to separate those data points into 3 separate clusters, whereby elements in the same clusters are similar and elements in different clusters are dissimilar. So example of this is when you're doing maybe image recognition and stuff like that. So choices made before, and like for example when you use your phone to take a picture, then you see some kind of square brackets that's being put on the face of the person. So that one is like, oh, it's trying to detect whether you have a face or a non-face. If there's a face, put a square on it. So choices made beforehand regarding the number of processes are to be generated. The criteria for measuring similarity and the representation of objects will play a role in the classification, which occurs as a result of applying clustering algorithms. Now, finally, talking about classification. Classification algorithms uses human-labeled training datasets where the categorization and classification of all feature inputs is ruled by these known labels. So, as I said earlier, before, like when you said you left or you stepped out, like your RGS report or RGS analysis, RGS model, where you label that, okay, if this person transported between 0 to 7 days, put as this particular RGS1, is between 8 to 30 days, put as RGS2 and all of that. So it's already labeled. So this classifier uses the concept of supervised learning. That's why it is supervised, because it's labeled beforehand. So it's already known. I'll just say, okay, when you find this kind of people with this character, put it as this. So classification rules set by the training data, which has been labeled previously by domain experts, are applied against raw unprocessed data to find out the appropriate labeling. So classification is often applied by email services to try to segregate spam email before instant in our inbox. So they also use this for identify spam email, because it's already made. They have some set of what they are looking for in a particular email. So if that threshold is met, so if some set of words are found in an email, there's a threshold where if the threshold should pass it, then that email should be labeled as spam. Then it's just going to into your spam or junk folder. So in an email containing a set of words or phrases understood to commonly occur in a certain class of spam mail and delivered from an address belonging to a known botnet, classification algorithm can fairly correctly label and identify the email as harmful. Um, and also talking about out workflows, SARS are SPSS and most statistical analysis applications include powerful tools for generating workflows. Most of these tools are intuitive UI that make data visualization, especially as math visualization, like really math digital. So math scripts also enable generation of statistical analysis workflows. At the final data exploration or visualization stage, you can export all this information into readable format like JSON or CSV, or use tools such as the Tableau desktop or Tableau public, as you wish. So the Marat architecture sits on top of Hadoop platform, which we have seen showing the Marat architecture. So Hadoop embodies the programmer by separating the tasks of programming MapReduce jobs from complex bookkeeping and all of that. So say MAP provides programmer-friendly abstractions of complex statistical algorithms ready for implementation. So what do we mean? We already have statistical algorithms that will do this computation. It's just like I want to do I have a list of numbers 1 to 50. Instead of me to now carry pens and be doing 1 plus 2 plus 3 up to 50, there is a function in R that will help me do that. I'll just have to write sum and pass those list of numbers into that. That will do the calculation for me. So there are statistical algorithms that will help you perform some stuff without having you to think about what is behind it. All right. So I think that is basically it here for this session, and that will be the end of this module. Module 3 data analysis using also. We are going to into the next module, which is where is it? I'll be talking about big data analytics methods. Do you have any questions before we go into the next module?
No question.
Okay, fantastic. Fantastic. Uh, let's quickly go over the next module. Mm, okay, here talking about implementing a big data solution. So in this session, we'll be explaining the steps to perform the envisioning process before implementing a big data solution, follow a prioritization process for big data use cases, explain the steps to perform a solution engineering process that can be used to implement a big data solution, and also explain some common challenges to implement big data solution. So I hope you're set. So let's get ready. Get started. So the envisioning process defines how big data can power key business initiatives. So how can we make use of the available data sets to make good business decisions? So and where and how big data and advanced analytics can be developed to transform a business. The business organization use big data to power their key business initiatives as follows. So uncover new revenue opportunities to impact marketing and sales, research and reduce costs in various divisions of business, obviously, mitigate risk across all key operational and financial aspects of organization's value chain, gather new customers, product and organization operational insight. So these are some of the few things you can achieve with a big data. So the envisioning process helps the business analysis stakeholders to understand the possibilities that open with respect to the new big data sources and new big data technologies. Now, following figures gives an overview of the envisioning process. First one is to research. So this is to identify key business initiative objectives and timeframes. So what are the key things we want to achieve, and what is the time limit we have? Analyze, prepare sample data. So let's come up with the sample data. Tens out insights. So get insights from that data. Then let's brainstorm. Envision potential of big data against business initiatives. So let's think about it. With this little data we have been able to get uh, and get these insights, what do you think if we could get more data from several sources and combining this available data set, what can we derive from it? Then here the next step we're talking about prioritize. So after we brainstorm, we've come about ideas and all of that. Let's now give those ideas. Okay, prioritize the opportunities, identify the impediments, that is the risks and all of that. Then also last step, which is document, capture analytics opportunities and recommend the next step. Now the big data envisioning process involves a number of steps that need to be executed. So let's see the next slide. So the first thing, which is research and interview, like to understand the targeted business initiatives. Here, prior to the envisioning process, the business analytics teams need to identify the key problem scenario, or the target business opportunity, challenge, or initiative. So after establishing the target initiative, the facilitation team takes over. So this typically consists of a lead facilitator which knows about the subject and also talking about the subject matter expert which knows about what is at hand. He knows about a lot of things to be considered in this aspect. And a data scientist or analyst which can help get data from different sources. So the team conducts interviews, take note of the important points, initiatives, and issues. Then going forward, talking about prepare data and conduct exercises. Now, after identifying the target business change, the facilitation team collaborates with the IT team to identify and acquire a relevant sample set of data. So the data scientists and analysts explore and reach and analyze this data using develop analytics, so advanced analytics, data visualization techniques, and various statistical software. So the data science analysts can also work together with the IT to also identify this data set we're talking about. And conduct a visioning exercise to understand what is possible. So client-specific stories using analytics with the data are created after trying to analyze to identify patterns and all of that, to be able to see what is actually possible with this data set we have. So, so client-specific stories using analytics with the data are created as illustrative examples to get the business and IT participants to start thinking about what is possible to do with this access to more detailed data. If you have more data from different sources, what do you think you can actually achieve something great out of this? So after that's after having to analyze the sample we have, so they cannot think, what if we have more data set? Then going up to the next slide. So brainstorm and prioritize. Here the team brainstorms to leverage big data operational data coupled with advanced and predictive analytics power the business initiatives. Now, the team can review the client-specific envisioning exercise for visualizing the possibilities with the new data sources and advanced analytic tools to making or for making implementation decisions. Now, uh, so the team can leverage the client-specific example for creative thoughts process with respect to the way other organizations are leveraging data to provide business value. Now, during this prioritization process, the facilitation team judges each use case prepared before based on its relative business value vis-a-vis its implementation feasibility. So these use cases they are determined or prioritized using what we call the business value and the implementation feasibility. So how feasible is it to implement this solution and what business value will it be bringing on the table? So this is going to form the XY plot or a 2 by 2 matrix. So we're going to be looking out for a solution that is highly feasible to implement and is going to give us great business value. Moving on to the next slide. Also capture implementation risks. To capture implementation risks and business value drivers, the final efficient step is to summarize the identified and prioritize business opportunities and recommend steps for deploying this particular solution. So key interview findings as related to the targeted business initiative are being made, analytic use case that came out of the engineering process, the prioritization matrix results, and also recommending next steps. So here the prioritizing use cases. So the prioritization matrix is a tool for driving business and IT collaboration and agreements around identifying the right initial use case for the big data journey. So the IT guys are the one that are going to talk about the implementation feasibility because they are the one that want to implement the solution and the solution engineering because they are the IT guys. Now it's now the business guys or the stakeholders, business stakeholders, okay, with this account, this is the value this can bring on the table. So the business uh, unit, which is the stakeholders and the executives, are the one that are going to tell which position that use case is going to fall on the business level, business value axis. Is it going to be of high value? And is the IT guys as the responsible for where it's going to fall on the implementation feasibility axis? Is this feasible to implement and all of that? Now, prioritization matrix process. So the prioritization matrix process starts by documenting each use case, identifying the brainstorming and evaluation stages. So the business stakeholders are responsible for relative positioning of each business case on the business value axis, while the IT stakeholders are primarily responsible for the relative position of each business case on the implementation feasibility axis. So that considers data, technology skills, and organizational readiness. Okay, so let's see this next we go to see how this looks like. Now you're going to have something like this, like a 2 by 2 matrix. This is like the center, and we have 4 axis. This is the implementation feasibility axis, and this is the business value. So at this bottom, you can see you have low implementation feasibility, and at this corner you have high implementation feasibility. At this bottom, you have a low business value, and at this you have a high business value. So where does II falls in this right top corner? So any use case that falls there says it has high implementation feasibility and a high business value. So you're going to consider any use case that falls around this right top corner here. Now talking about um, discussing the use cases that falls on this matrix here. So why use case B more or less valuable than use case A? Which business drivers or variables make use case B more or less valuable than use case A? So the question start asking why use case B less or more feasible from implementation perspective than use case A? Why implementation risks make use case so which implementation risk make use case B less or more feasible than use case A? So it's critical to capture the reasons for the relative position of each use case in order to identify the critical business value drivers and potential implementation risks. Now, moving to the next slide. So talking about the prioritization matrix traps, we have 3 traps. Now these are the 3 traps. This left top, left bottom, and right bottom. This one is the sweet spot. They call this place the sweet spot. Now, zone of mismanaged expectations. So which one do we call the zone of mismanaged expectation? Having each business value, these use cases are the least probable of executing successfully and therefore must be avoided. Having high business value, these use cases are the least probable of executing successfully and therefore must be avoided. It means they have high business value, but they are very low to implement. So the feasibility of implementing that solution is very low. So those one are called the zone of mismanaged expectation. So those are the one that falls at the left top corner because they have high business value but a low implementation feasibility. And we have the one of user zone of user disillusionment, zone of user disillusionment with little business value, even if this use case, sorry, with little business value, what's this? With little business value, even these cases are easy to execute. The business and IT personnel should avoid them. So these are the ones that fall at the right top, the right bottom, the right bottom. They don't have they have little or no business value, but they are very easy to implement. So what's the good of it? If it's easy to implement the solution, but it's not giving, it's not worth it at the end. It's not bringing in money. It's not value. So this kind of use case are called zone of user disillusionment. And you have zone of career limiting moves. Zone of career limiting moves. So with least business value and low sources of probability This or feasibility, let me put it this way. These cases should be targeted by no person belonging to either business or IT because the one that falls at the left bottom here. It's not easy to implement and it does not even give a good business value. So why should we even go for that kind of use case? So, so use case falling into the above three zones are avoided because they are either provide little business value to the business stakeholders or are too risky for IT implementation. Now, uh, let's let's go to mismanaged expectations. So, the solution engineering process. Our solution engineering, as shown in the following figure, is a process for identifying and dividing organization key business initiatives into a business enabling capabilities and supporting technology components to support this decision making and data monetization efforts. So the first process is to understand how organization makes money. So you want to create a solution engineering process. You want to build a solution engineering process. So first of all, for a particular organization, you have to understand how does this people make money. After you understand that fact, then what do you do? The next step is to identify key business initiatives. So what are the key things you should look out for to actually achieve this, to achieve your goal? So three, brainstorm big data business impact. Brainstorm big data business impact. Then four, flesh out use cases. Look for use cases you can consider. Then prove out use cases. Like, okay, use case one, if I do this, will you give me what I'm looking for? Then you start removing some use cases that will not be relevant for your solution. Then the last step is to design and implement big data solutions. So after you found the use cases that are going to be are going to solve the problem, then you design and implement big data solution. Let me go to the next step. So first of all, talking about how the organization makes money. So step one, understand how the organization makes money. So the key to the solution engineering process is an upfront investment of time and creative thinking in order to grasp how an organization makes money. Because what's the essence of creating a solution engineering process if it's not going to add value to the organization? Doesn't make any sense. So identify the key business initiative of an organization and understanding their desired impact on the organization's strategy now is necessary. The next, you need to identify a way which drives the money-making capabilities of the organization. We know that across most industries, like the major industries, 0 to 5% of customers drive most of its profits. So those are what we call premium customers. Like you have 50 to 60% deliver no profit. All these people they're just there. Then you have 10 to 20% who deliver negative profit that they even put the companies at loss. So the second stage is to before we continue, an organization can pull many levers to make more money by either increasing revenue or reducing cost products or services. So increasing revenue includes the following initiatives: growing the number of premium or gold card customers. That is, here you can see increasing the percentage here. If I increase this one from 0 to 25% to 0 to 30% or 0 to 35%, then my revenue is going to increase. Obviously, developing store or site traffic, reducing customer attrition, that is, customer that are leaving or stop using the service and all of that. Starting revenue per shopping occurrence, increasing private label sales as a percentage of market basket, increasing cross-sell and upsell activities. Uh, cross-sell and upsell. Upsell is more of like trying to um, sell more products to like the premium customers, and cross-sell is more like I think this instead of me to sell this customer and this product to this particular customer, I think this other customer is going to value this product better and all of that to improve revenue. So optimizing promotional effectiveness. So this one is like talking about maybe you have 500 customers. You have 500 customers. So out of the 500 customers, if you can identify customers that are already churning away, that are already leaving the with maybe through up a particular service. If you have like 200 of them, just maybe just 100 of them out of 500 that is going to stop using a particular service, you can just send some promotional campaign to them and stuff like that. But if you can't identify those 100, it means that I will have to send promotional campaigns to 500 customers, which is not cost effective. So if you can identify customers that really to be to get some campaigns necessary for them not to stop using your service, then you just have to campaign those set of customers instead of having to blast your campaign to the whole customer base. This is going to optimize promotional effectiveness in that regard. Now, the last slide here. So reducing cost includes the following initiatives: reducing inventory and supply chain costs, reducing fraud and shrinkage, improving marketing spend effectiveness, and that's the cost of having to even to blast campaigns, like I mentioned earlier. The cost of campaigning 100 customer can be compared to the cost of campaigning 500 customers. Consolidating suppliers, improving on-time pickups and deliveries, optimizing merchandise markdowns, improving access to installation and terms and all of that. Now, building upon the observations, the facilitation team will prepare to discover new sources of customers, products, and operations insight that will enhance the money-making ability of the organization. So here we've talked about the first step. So as we proceed, let's see in the next slide. Now, this is step two. So just give me 2, 3 minutes. I'll be back.